That webinar will be devoted to the digital tools, and it will be presented by as well by Université Luleå in Sweden. So the panelists are supposed to be Jean-François Parmentier, who is right with us today. Jean-François Parmentier is from Université de Toulouse, INP-ENSET, is the instructional designer at INP-ENSET, and as you can see on that slide, he is focused on the dissemination of evidence-based teaching methods, and is also associate researcher with one research lab in Toulouse. We are supposed to have Eric Evgren from Luleå Technical University. I say suppose because I have no news from him and no news from Luleå.
Well, you do. So hi, my name is Peter Parnes, and I'm a professor at Luleå University of Technology, and the others are coming. There was a conflicting meeting that just ended.
Okay, so I hope Eric Evgren could join. So Eric Evgren is supposed to meet us soon, to join us soon, and Laurent Deren is CDO at Université de Toulouse Superior, and is currently in charge of the digital transformation with the School of Engineers. So well, here is the outline of the presentation. You can have a brief look at that, and Jean-François will be the first speaker. So he will describe several tools and activities based on digital tools, such as all the things that could be done with Moodle, real-time polling devices and systems, multiple choice questionnaires as well, and social annotation platforms. And all the speakers will have to describe several approaches, several functions, and they will give an example. So this is not a real training session on the a specific program, specific web platform, and so on. This is a global overview of what could be done when we speak about digital tools. So, and the second speaker will be Eric Evgren. He will illustrate the social annotation platform and the function included as digital post-it with Mural or Padlet. And Laurent Deren will be the last but not least speaker. And so he will introduce 6 different approaches and digital tools for experimental activities, and describe some of them in the following slots. So just a brief overview, general overview for people who do not know probably all the details from UNIVERSEH. So all these details could be found on the website here, which is and this address is recalled this on that slide. But just as a brief overview, you probably know that 5 partners are involved in this program. So Université de Toulouse, of course, HHU from Düsseldorf, Université du Luxembourg, UNILU, Luleå Technical University in Sweden, and AGH in Krakow in Poland. And under the umbrella of Toulouse, Université Fédérale de Toulouse, you can find as well 5 schools of engineers or institutions such as UNIVERSEH Superior, INP with several schools of engineers, TBS, Toulouse Business School, Jean Jaurès Université, and Paul Sabatier University. Jean Jaurès is for, well, you can find these details on the website. So as a some complementary elements for describing UNIVERSEH. The objective is to build a comprehensive university in the space sector, including all the disciplines and all the sectors which are listed here, from science and engineering, of course, but also including business, medicine, social, human science, arts, and innovation and entrepreneurship. We target 4 segments, close to the Earth, so observing the Earth from the space, how to create rocket satellites to reach such this zone close to the Earth, and as well how to go further on the Moon, on Mars, and so on, and to develop space bases, and how to for space exploration. The project is for 3 years, next coming, let's say, 2 years and a half, because the initial date, the starting point was on November the 1st last year. There are 2 aspects, the training program, which is funded by Erasmus Plus and by national fundings as well from different national agencies. But we have also in parallel another program which is called Beyond UNIVERSEH, and that one is funded with a reduced budget from compared to the one that we have for the training functions. The research budget is funded by H 2020. So after the 2 years and a half, then we will have an evaluation. We'll have to pass a kind of exam evaluation. I don't know what would be exactly the process to go for to get a go signal for 4 additional years. So who are the partners? There are their websites here, and they are in charge of different work packages, and that you can see here. And the packages which are involved in this webinar here are number 2, number 3, and number 4. And you can see that one of them is managed by Université de Toulouse and the other one by University of Luleå. So that's why the speakers come from those universities. So just 2 slides on the WP3, if you don't know it by heart so far. So one very important work package in WP3 is the 3.3, because we have to design to create 10 new courses, and new courses with each new course will have to be 3 ECTS long or equivalent to 3 ECTS. So in order to develop and to support the development and the design of these courses, we have to create and use new things which are not completely new for a certain number of you, but including digital tools and including digital active methods. And well, we have questionnaires, we have a mapping of existing training programs, and we will have as well to develop new programs, not courses, but programs at the master level, bachelor level, and doctoral level. And all those things are included in the WP3. And what are the general criteria for WP3 courses that we have to develop? Well, as said before, we have to develop a minimum number of 10 courses. The target is 3 ECTS, which could be considered as 30 hours for the students, not 30 hours for the professors especially, but mostly 30 hours of supervised work for the students. And these courses will have to, in order to be to get the labeled UNIVERSEH, those courses will have to reach 5 stars out of the 3 stars, the minimum number of 3 stars out of the 5 which are listed here. European means that, well, they are the courses will be created by at least 2 European partners. Interdisciplinary, well, it sounds pretty clear. Learning techniques, there will be a dedicated webinar next week, which will be organized by LTU. Digital content, that's the webinar we are attending now, and multilingualism will be further discussed in the working groups. So all these things will be validated soon by the Academic Council. And well, in here, oops. And then I leave the floor to Jean-François Parmentier, who is the first speaker for this webinar dedicated to digital tools. François, the floor is yours.
Thank you. So hi everyone. So okay, sorry. So in case you see my presentation, so we'll talk you of an overview of some digital tools to facilitate teaching. So first, a key point before being further in digital tools. So there are many digital tools you will heard in the future, but one thing to remember, it's all these tools are not magic wands. Of course, it's not because you apply a new tool that a student will suddenly learn everything. And the key point is to use properly digital tools and to focus on cognition if we want to increase. So digital tools are only tools to facilitate teaching. So they can facilitate, in order you can make things you won't be able to do it before. So it can, facilitate good teaching, but of course it can facilitate also bad teaching. So the key point in these tools is to understand how you can use it to create meaning. So just I will make you a demonstration and just focus on how the mind works in the key point, and I will use it, what I say now, when I will present the next tools. So I have prepared for you a question, a multiple choice. It's also an example. So I will put in the chat a link to an online tools. So it's for demonstration, which the name is iQuiz. And so in the chat, you will find the link. You have to, if you connect yourself to iQuiz, you will be asked whether you are teacher or student. So here you have to be a student one. And I have put in the chat an identification number, which is the identification of the session today. So it's 11283. So you are here, you are click on the right button student, the yellow one, and you will see on my screen, a question. And me, as an instructor, I have opened the question. So if you connect, you can answer. And I see that some people answer. So please read the question and try to answer. So I see that not all of you have answered the question. I see 9 people connected. If you have trouble, you can ask on the chat, of course. Because I see that there is 20 participants. So the key point of this tool is that the question is not in the tool. The question you see is on my slide. I write the question with what I want, and the tool. Yes, thank you, Laurent, for the link. And the tool only deals with the voting system. So I will stop. Oh no, it's not so good. I will end the question. So you will see all the items. So let me show you what I see as an instructor. Here's what I see. I see a number of students who answer, and I see the histogram of people who answer, and they give me an idea of how many students, how many, what people are thinking. So the key point is, I think the good answer is answer 3, disagree, while a lot of you has voted mainly number 1. In fact, because if I ask this question, it's because I know that a lot of people will choose 1 and 2, and that's what I will have chosen before. And this is a vision when you see that the brain is like an hard drive. You give an information and it stores it. And in fact, it's false. We always interpret information. And the good thing to see, the good way to see, is that learning is about making links between information. So as a teacher, you give information, for example, 2 pieces of puzzle, and the brain tries to relate, to link these pieces. And just to finish, a few examples. If I say you 2 sentences, I have to go shopping, and I say another one, but I'm out of gas. So what will you do when you will connect? You will try to make sense. And in order to make sense, you will have to relate the sentence with your prior knowledge. You know, for instance, that cars need gas. Okay, and you also know that usually people go to shopping with cars, by car. So you will conclude that I will not be able to go to do shopping. Okay, and in order to conclude and to understand what I say, you need to make inference, to make hypotheses, and you will have to relate the new information to your prior knowledge. And this is really a key point, is that all tools, you need to focus on that. Don't try to test only content, or try to test if people make sense, and encourage students to make sense and use it to make good questions and to relate what you say to prior knowledge. So this is the key point of cognitive psychology. And you will see that there are different ways to use tools. So the first one I have shown you is that real-time polling devices. So I just take the, okay. So real-time polling devices. So there are many devices. You are in face-to-face. You will have flashcards. It's low-tech tools, but it's okay because students show flashcard. You can do it at distance also. And the key point is to have only an idea of who answer what, how many of students answer blue, or how many of students answer red. And it's okay. In fact, this low-tech tool is really good. But you can have many more one, for instance, clickers if you are in face-to-face session. So you, as an instructor, have a smartphone, and student, you see, have some QR code, and you scan it, and you will have the answer for each of your students. You will see that Pamela have make the answer D, for instance. So we have more than the flashcard. You have individual score, individual choices, and it is recorded. So it's very used in face-to-face session for small group, for instance. And it's really low-tech because only instructor have a smartphone. Students have only piece of papers.
Jean-François, moi je vois que l'écran de réponse au questionnaire là. Ah
bah oui, il y a un souci, je pense. Excuse me.
Ouais, Laurent, pour toi, pareil?
Yes, there is a... OK.
Ah voilà, là c'est mieux là.
Oh, OK.
On voit tout ça.
Sorry, so flashcards, I say, and I talk of clickers. So you see, students have QR code, instructor have a smartphone, the instructor scans the answer, and it's all recorded. You know who have answered what choices. So it's a good solution for small classroom at face-to-face. And you have specialized tools like clickers, maybe you know, that are very easy and very good. And among that, you have also all smartphone application or computer application. You have tried iQuiz. The key point of iQuiz is that it is only focused on making the poll. All your questions are written with your slides, and you can use what you want. You can use equation, you can use picture, and it is a key point that it's really easy to use, but there were no recording or thing like that. And it's good for real-time polling. Zoom, if you use Zoom, at its own built-in polling system. But if you use it, it is limited to textual questions. So you can't use equations. You cannot use picture, only textual equations, or you should put your question in your slides. And one is very known and very used is Wootlap. Have many possibilities, but there are many more real-time polling devices. All have their drawbacks and the strengths. So you can make the choice you want. So so here I have finished the overview of real-time polling devices. So if you have any question, you can ask orally or you can or in the chat. And now, yes. And now I will switch if it's okay. Yes.
There is a question from Andreas.
Ah, yes.
Sorry, I may have missed this. Is it required to have licenses for these tools, or are they available freely? Because buying licenses is always like an issue.
Yes, eQuiz is freely. Yes, thank you, Laurent. It's totally free. Wootlap, you need license. And Plickers as a tool is free for less than 35 students, I guess. Of course, clickers, it depends on which clicker you buy, and it's expensive. It's very good, but expensive. And some you can combine for some clickers face-to-face with distance in the same time. But it really depends on which clicker you can buy. And as say Laurent, iQuiz is okay up to 1,000 students. Okay, it's 1,000 or 100?
No, 1,000.
1,000. Thank you. 1,000 students. So it's a good and easy. eQuiz is good and easy. It's why we develop it at University of Toulouse. But others are okay, and usually others have more functionalities, more the various kind of questions. But in fact, if you with multiple choices, you can really do good things. For instance, this is not a good multiple choices. What is the French capital? Bordeaux, Toulouse, or Paris? Okay, everybody knows the answer and know what you should answer here today. But remember, the brain say, okay, learning occurs when you try to make sense of the material you encounter. So here is not a good question because students are not actively make sense. Another example of good multiple choice. Okay, it's a very technical one, but you make a long mathematical derivation and you ask your student what for. Okay, this is an example. So you have answers that reflect student thinking, and you have explanation. It's a good question. So focus. So keep on. Multiple choices are working if you are using good questions, and good questions engage students in thinking, in trying to make sense. So I will not make you courses on this topic. So MCQ are okay, but there is limitation. For instance, you don't always know why students answering correctly. You don't know how they think. Maybe they answer correctly, but not for the right reasons. Usually you have only closing questions. And importantly, in the exam, oftenly you will ask them for written explanation. You will ask them to explain their rationale, not just to check. For that, to increase the potential of MCQ, there are two tools, Elastic One and MyDalit. The both have been developed independently. Both are open sources. MyDalit is from Quebec, I guess, from Canada. And Elastic is from French, from Toulouse. So I will talk to you Elastic. It is our computer science research lab, IRIT. And both are working exactly, or nearly exactly in the same way. So there are 4 phases in these both tools. So first one, you have questions that can be closed or open-ended. It can be used at distance or face-to-face, synchronously or asynchronously. Then the student will have to provide his answer, the choice, but also an argumentation, and also the confidence degree. And finally, what is very interesting in these tools, so there is a confrontation of point of view. The learner have to give their opinion on others' learner contribution. They have to evaluate between 3 and 5 other contribution. Not all of the other students. If you have 200 of students, it will not be possible. And finally, you can share the result and make a discussion, because as an instructor, you will see what are the answer of the student and what are the most voted answer. I will make you a demonstration. So I will share here. I will share what I see. So this is the interface as a student point of view of Elastic. So it starts with multiple choices, as everything. So as the instructor have written, of course, these multiple choices before. So the student have to select his answer. For instance, he will select answer 6 or 2. And he will write his explanation. I think, okay, I think blah, 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 blah. It's okay. It's just for demonstration. Okay. So he explains his rationale. It's interesting because at the exam, you will evaluate these kind of things. And he put his confidence degree. So it was not really confident. So it's the first phase, choices, explanation, and confidence degree. And when he submit, I have lost my connection, so up is okay. Okay, I will say okay 2. I have opened 2 blah blah blah. Not really confident. And when he submit, here are presented other several alternative responses. So here are the answer of other students. Of course, here there are not other students. So this morning I've played many roles of students. So you imagine that in your course, other students have made this guy have made choice 5, and here is its rationale. And I can give my opinion on the rationale. I say, okay, I agree with him. Or choice 1, oh no, in fact, I agree with him, but not with him. And here, oh la la, it's a long explanation, maybe he's right. I can make what I want, and then as a student, I can change my choice. I think choice 3 is a good one, for instance. Choice 2, choice 3, and okay. And I can change my rationale. So I can make another text. I know I'm confident and I submit. And I will have access to the histogram. So I think the green one is the correct answer. So it's okay. And I see other student rationale. I can see what explanation. So here is the tools, MyDalit and Elastics. So key point of this are it extends multiple choices. They can be connected to learning management system, such as Moodle if you use it. And there is rational written argumentation and confrontation of point of view. And they are really easy to use. You can use it in real time or face-to-face at distance. Any question on those tools?
Looks really nice. This Elastic, it's a little bit like a Mentimeter, but more fully digital.
Sorry, I don't understand the question.
Mentimeter, do you know that one?
No, I've heard about it, but I didn't use it.
It's a little bit similar, but that one you usually use in the classroom, and the students discuss between themselves and vote. But this is sort of a digital system for doing that. with having
Yes.
a discussion, a little bit of discussions between the students and changing
Yes.
of ideas. Yeah. Nice.
Exactly. Yes, it is exactly that. Yes. What you describe is called a peer instruction. A tool is Mentimeter. So first student vote, then they discuss with their neighbor in real time, 3 minutes, for instance, of discussion, and then they revote, polling system. And these two tools, MyDalit and Elastic, have tried to make this with written explanation and maybe at online. So this kind is to really mimic what you describe. Another point of tools I have remembered this morning, but synchronous group work. In fact, many tools such as Zoom, Big Blue Button of Microsoft Teams, and have to have a functionality very, very good, which is called Breakout Room. Here, it's a classical video conference, like we know, the teacher speak and the student hear. Okay, you can ask multiple choice, it's good. But there is something called breakout rooms, when you can split students into small private conferences. With only few clicks, you can split them. And as an instructor, so they all have private conferences, like we'll have in face-to-face when you make tables and student work in group. So you can do it at distance. And the instructor can switch from one group to another one, try to help students. And if students can say help, so the instructor can come to his room. It's really like face-to-face. And he can share small information to all groups, but he can come back in one click in whole class. So he can exchange between whole class and group discussion. So breakout rooms is really, really a good tool to teach online. Yes.
A comment about breakout rooms. You can also predefine the breakout rooms so that you make the groups beforehand, depending on your needs.
Yes, exactly. Yes. And you can keep the same groups every time you teach for every courses. So it's cool because students can learn to learn their colleagues and try to work with others. So yes, and you can also alternatively let students choose their own breakout, their own rooms. Okay, you have many or randomly if you have many students. I use it breakout rooms, for instance, for 200 participants, and it's okay. They will have 50 rooms, and it's okay. It works.
However, it doesn't work if you have more than about. If you have much more than that, you have to make really big breakout rooms. If you have like 400 students, then it won't work anymore.
Yes. In fact, breakout rooms, you can in Zoom you can have only 50 breakout rooms. And breakout rooms work if you have 3 to 4 people inside or 5, but not more. It's really difficult to work in group at 10 with 10 people. It's not a group. So all of this was for synchronous, while Dalit and Elastic can be used both synchronous and asynchronous. So now I will focus on the other part, so the work between lectures, the work between sessions. Just a point on Moodle. Moodle, I think many of you use it. It's learning management systems. We all use it in French. It's open source. But there are many more. I think you can do exactly the same with Blackboard on other one, depending if you have. The point of view we have here is that Moodle is an entrance door. It's the key point where students always go to Moodle at the beginning of each of their courses. They go to Moodle, they enter Moodle, and then they will have plenty of activities, plenty of things to do, but it's the entrance door. And if you use Moodle for asynchronous work with many things to do, many activities, a key point in using it is to be clear on what you want from the student to do, because the students will go to a new page, even it's Moodle or Blackboard or any one of the learning management systems. They will ask a question, what I am supposed to do, where, how many times. So here it's a sample of the way it is organized in one of courses. All is divided into activities. So small activities where it is always stated what they have to do and how many times they will have. And just beyond, you will have activities. So a link to a video, you can link, a questionnaire. So in Moodle and other LMS, you can have, of course, multiple choices question. You can also have open-ended questions. So open-ended, they will not be graded automatically. Of multiple choice are automatically graded. So here the teacher have to grade if he wants. But the key point of this open-ended question that it engage students in making sense of information. So even if you cannot read all the answer for your students, making them to think and to write is very good for their learning, in fact. So even if you can correct the answer, even if you can provide feedback to all of us, it's already a good thing to make them think deeply and asking open-ended questions. And in Moodle, you have also an upload where students can drag and drop an assignment, a PDF file, a doc file, what you want, and students can collect all the assignment and correct it, of course, and grade it. Another thing that's really good in Moodle, but I think you can have, you can follow the progress of all of students. Here are the name of students horizontally, and vertically, all of the are the activities of the courses. So when the student have linked to the link, for instance, video presentation, it has been checked automatically. So I know where are my students, where they have clicked or not clicked, what they have consult, and I can trace all my students. I can adjust what I expect from them. If I see that I have expected them to make 10 activities, but in 2 hours they have only made 3 activities, I'll say, okay, maybe there is a problem, and I have underestimated the time needed. So it's a key point. And finally, the way of your pages is also useful. I will switch my slide to show you another thing. So next it will be used. Oh, this one, if yeah, you have courses in Moodle, and if you have many things to do, you can put it in tiles. They click, and this is all the activity in this chapter. And it really enables students not to be lost. It helps students to know where they are, what they have to do, and to have plenty of data on a single page. So we use Moodle a lot for asynchronous work and autonomous work, where students have to work themselves. So here, okay. And I just check the timing, sorry. It's okay, a few minutes. So I follow. It's not what I want to share. So, okay, sorry. So next one, Moodle have a peer assessment module. Peer assessment is very good. So there is Moodle, there is other peer grade online platform. So the key point of peer assessment is that each student submit an assignment, his own work, and then they evaluate each other according to criteria defined by the teacher. So as a teacher, you define a criteria grid, and each student evaluates 1, 2, 3, 4 work of other students. And then each student receives feedback from their evaluators. So again, in step 1, students submit his assignment on Moodle, and he receives between 1 and 5 works from other students to evaluate. And he will use the criteria you defined, and he send back the grade and the feedback he has put, and he will say for his homework, for instance, 16, 50, 17, and will save the work. And he will save feedback. For instance, when he grade, he have many criteria. Here, for this criteria, he have to put a grade for if it is a clean code or not, for instance, in computer science courses, and he will have to put explanatory feedback. And this is a key point, is that because students have to evaluate work of each other, it's very intensive cognitively, so it's good, but and he will receive feedback from other students. So feedback from other students will help him to improve himself, will help him to learn more. So you really use the power of students, in fact. And you can use it with many, many students. Here, it was used with 300 students. So it's time consuming for a teacher to configure all, but it's less time consuming than correcting 300 individual work. So it's an alternative way for students to have feedback on their work when the teacher cannot grade many individual works. And so this is good things to use inside Moodle, or we can find other tools that do it. And finally, I will show you a tool specialized for pre-class reading assignment, reading or watching assignment. But usually, imagine you are a teacher, you have a reference book, or you have write your own textbook, and you want students to read it before coming to lecture, before coming to class. So there is a special tool developed here for that. The name is Perusol. It was developed by an American university. So I will share you how it works. So let me share my screen again. The teacher have uploaded the textbook, and here is a student. The student view. He say he have an assignment. He say I am here. I have something to read, so I work on assignment. I can read it, of course. There is nothing new and nothing more than a PDF viewer this time. But what is really interesting is that when I have a question and we ask students to make comments, we actively say, students, you need to make 3 intelligent comments on the textbook. So you say, okay, with the wrong person, I select this one, I can make a comments. Okay, I think that, and as a student, I can make any comments I want, blah, blah, blah. And what is very interesting in that, and I will show you now real courses that use it. Let me open it again. Is that first one, the instructor see all comments of students, but if you have many students, it's not very good. But where is my what's happened? Sorry, there is a small technical. Okay, I get it. So our instructor I see here, but students see all comments of other students. Here it's a real courses. So I will see here all the students, and you see a first student ask this question, another student has answer. And here, as an instructor, no, not me, no. Another student have also comments. So it's collaborative annotation system. So students don't learn alone, they learn with other students. They don't read alone their textbook, they read with other students, and all students can read. Here, it is an instructor comment. So question, a student make a remark, and the instructor give feedback. And so you can see there are a lot of comments from students. So students really use it and discuss. And what is also good is that student, teacher have an overview of how many students. You can see that there are 1 hour and 46 minutes of reading. So students have passed 2 hours to read the document. You see how many have done comments. Is the most voted annotation, because when a student think a comment is good, he can like it. So as an instructor, I see what are the most liked comments, so I can focus on this comment and give feedbacks during the beginning of my next lecture. And more good, it grade all comments. So here are all comments made from the students, and the system using machine learning give an automatic grade between 0, 1, or 2. So if I show here are the only one who have been rated as 2, and you see if I check, no, hopla, well, score 0, of course. Okay, you say this no ID. Okay, this guy have put no ID. It has grade 0. Okay, it's okay, but these good comments have been graded with a note of 2. Yeah, the grade is 2, and we have verified here that the algorithm used is very good. So the score, it put 0, 1, or 2 to each comment is reliable. We have checked it with an instructor who have checked all the score made by the software, and say, okay, it's a good score. 0, 1, 2 is okay. So you can, and it's designed for that, you can use this grade as a grade for your courses. And we use it, we say to the student, you have to read these 10 pages for next week. You have to put good comments, and we explain you what does it mean to put good comments. So we have a manual for that. And the score the software gives to you will be counted in the score of your module, of your courses, for 5%, so very, very small part. But these 5% make student work. And we have many, many comments. Yes, we have 2, it is the number of comments, nearly 300 comments. So it's a tool that really engage students in thinking, in trying to make sense. They have to relate. We say, okay, select a sentence and relate it to your prior knowledge. It's what we define as a good comment. Also, ask your question. If you have a question, ask it, and other students will answer and will help you.
Was it free, this software?
Yes, it's free for university. If you upload your own textbook, if you want to upload a textbook by a publisher, so your library, or maybe your library will make a deal with the publisher. They make a deal with many publishers. Okay, if maybe I can add manual. Yes, you see you have all publisher. I don't have, okay. So in all topics, for instance, all this, okay. Okay, you have many topics. Okay.
Great,
yes,
thank you.
Science, space science. Okay. Up, yes. Okay, magnetosphere, etc., etc. And if you use this, depending on what you do, it's the student who buys the book, or it's your library which buys the book for the student, depending on what you want. So, and developed by University of, I don't know if it's Princeton or another one, but a strong university. So that's okay for the overview, and I think my time is finished. Yes.
Yeah, you're right on time, Jean-François. Thank you very much. So we just have 1 or 2 minutes to take 1 or 2 questions, and short questions, short answers. No, so we can move to the next presentation, next speaker. So Eric, I will give you the right to be host, so you will be able to share your screen and with us. So the floor is yours. So next presentation from Eric Elfgren will be will be focused on the, well, let's say the way to perform digital post-its, and with some softwares. I don't know which one you will present, but I gave some examples such as Mural or Padlet in the outline of the presentation. So the floor is yours.
Yes, thank you very much. It's nice to be here, and I will talk about Mural, which is a software for well, making post-it notes and collaborating, and it can be really useful in classroom for group works, and it's very nice to combine it also with breakout rooms, so that the students work in parallel on the same space, on the same web space. But this can also be used for teachers and university employees in different workshops in order to brainstorm and come up with ideas and discuss together. And I have used it in several workshops at the university like that. I think I will start by just showing a little bit how it can look when we have done a workshop like this. Then I will go through a little bit about how to actually use it, and finally, if you are interested of getting this, it is free up to 100 users at the same time, and 10 sort of accounts. So that is a university license. Otherwise, you have to pay if you want more. So I will start with showing a little bit on how this can be used. This is a workshop that we did on developing a new educational program, and as we can see, you can have an outline to the right of the screen. So we start with the introduction. Here we have the agenda. This is in Swedish, but no matter. And then we can go on the presentation of the different participants. We had an inquiry discussing that, and then we talked a little bit about the different roles that we wanted to see for the students, and then what different specifications, what different specializations the students could have. And then we had, you can also make like arrows between different post-its, and you can also vote. You see the number of votes here for different things, so that you can connect them. And if you move something like this, then the arrow moves as well. You can undo what you just did by Control Z, just like you can in most softwares. And you can have pictures and stuff also included. And this then everybody can work on the same space at the same time. But it is usually nice to have a group work, so that you can also have a discussion between the participants, what they are doing and how they are doing it, and stuff. So that is a little bit of an overview of what you can use and how you can use it. You see, we can have post-it notes like this. You can have text boxes. You can have figures and different kinds and colors and stuff. So it's quite nice and in that way. So maybe I'll show you another example of how we have used this. This is a format that I like when you have different different discussion parts, and then for each discussion you have different groups, and the groups they put in post-it notes like this, and then we have a voting session where the participants can vote for which of these post-it notes that they like the most. You can show the different votes here. You can have several different votes in the same space. So here we have voting for the first discussion, the second discussion, and the third discussion. And then afterwards, you can also have some images. Here we had we talked about the constructive alignment and different what's it called? Different levels of understanding for the students. Taxonomies, yeah. And then you can just check the most popular ones. You can then copy and paste them here, and then you can make a summary of what they have done here quite easily within the same space. So that was an overview. So now I will show you how you actually do this. If you want to, you start by create a new mural, and then let's take for example, you can use a template. There are hundreds of templates. I have not found anyone that I have found really useful, but if you want to, you can check around a little bit and see if you find something that works for you. I usually just do my own template. That's easier than sort of trying to find something. But maybe there are some categories that you can use also if you want to. But I usually just start with the blank mural and I create it like this. I enter a title, University Digital Tools here, for example. And then I can invite you guys to do this. I will do it pretty soon so that you can try out a little bit of this yourself as well. But I will just show you a little bit how it's done first. If you double click on the screen, you can write a comment or something in a post-it like this. Yeah, I think that is, you can, like I said, you can undo with Control-Z. And now I think I will show you how to share this. It's quite easy. There are two different ways of sharing. You can invite people, and these are sort of collaborators and or well, owners, if you want to, of this document. But mostly you will use the visitor link, which allows people to come in and participate in the mural and put their post-its and stuff. But they cannot, for example, export it or start a vote or things like that. That is only reserved for the invited people. So you can also determine what this link allows people to do. So I will copy this link and I will go to the chat, paste it here so that you can come and join me. And when people join, they appear at the bottom of the screen. You put a name when you join, and as as a presenter, I have the option, for example, to call everybody to my point of this space, but I will allow you some time to join first. You can try to do some stuff as well. It's quite intuitive actually, and I usually use this without having any particular introduction. I have a 2-minute introduction to how to post notes and how to undo, which is sort of the most important things. But apart from that, now I can see that there are quite a lot of people here, so I can now. For example, I can focus on one of the, I can make my own here, start, I call this. And then I zoom in on this one and I can ask everybody to come to me. I can summon you. So now you see this start thing so that you see the same screen as I do. I can also ask to be followed so that if I move my screen somewhere else, then you will also see that. There are reactions that you can use. You can celebrate, and I can, for example, also, it's a little bit fun. I can celebrate. You see a lot of stuff on the screen right now. Right. Anyway, it's just some fun things that can make it a little bit nicer to work with. So to the left of the screen, you have a menu that you see. Here, the top part of that is text of different kinds. You can switch which kind of notes you want. If you want to make a round post-it, you can do that. If you want to make a square one, you can do that. If you want to have a text box, you can have that. You can also resize these things. You can choose multiple objects by shift clicking on them, and then you can resize both of them together or move them both together. So it's quite convenient to use. You can also have changed the for example the color of a post-it like this. You can put a link to some web page, for example, on this, and it is possible to, let's see, you can have a border, you can change the text size, reduce it or increase it. And you can also, if you right click on it, you can, if you are a presenter, you can lock things. I'm not sure, maybe you can also lock things. You can try it. If you right click on an object, you can, perhaps you can lock it too. Has anybody tried? And I can, for example, this round now, I lock it so that only facilitators can move it. So now if I ask you to come to me, so the round one, you can no longer move that or change that because I have locked it. I can, with the right click menu, I can also add things to the outline. So I can add the round here, for example, first step. And the outline, I can also add instructions and stuff with this. I see that someone has discovered that you can also put in icons. It's in the menu to the left. The third one from the top is icons. For example, a thumbs up, which you can also resize, of course. There are shapes and connectors, which is the second one, where you can draw arrows and boxes and triangles and stuff like that. And then you can also put in images. You can make a Google search, for example, UNIVERSEH. If I search for that, then it finds different images of the universe, actually. So I can put in, for example, nice picture of a galaxy here. So that was that. Voting is done. Now maybe you can, if you look at my screen instead of your own, because I don't think that you can see the voting function from your screen. So if you're back with my presentation now, you see at the top there is an icon that here we have a voting session. So I can start a voting session. I can call it discussion 1, for example, and I can say that we each have 5 votes. And who can end the voting session? Just me and facilitators. Okay, so now if you go back to your own screens, you can begin the voting. And you can, there's a short instruction as well. You can vote, you can also remove a vote, and you can vote several times on the same thing if you want to.
Okay, Eric, thank you. Could you come to the conclusion, please?
Yes, I am almost done. Okay. So if this is seems interesting to you, you can sign up for this at the mural.co/education. You can go and you can ask for a classroom membership for up to 100 students, which is free. And that concludes my presentation on Mural. Do you have any questions?
So just a few questions. I don't know if you have said it or not before. Just when you use it, no, so you use it in your course, in your lecture, I guess. How many students at the same time, and do you use multiple murals, such as small groups or things like that?
I have not used this with very large groups actually, so that would be up to you. But you can have 100 participants at the same time at least with the free version.
How many? Excuse me. How many? You use it? How many? I don't.
100.
100.
Yeah.
On the same one mural.
Yeah.
Okay. Okay. Thank you.
Yeah, there have been some questions written in on the. What about the fact that any comment can be removed by any students? That's usually okay. I'm not sure about that actually. You can lock things, but usually this is more of a creative tool than an assessment tool, and in that case it is not so important if they if someone changes something about this. And I think that I answered the other questions there now. If you have anything else that I missed, please give me a heads up.
Okay. Anyway, the question could be put on the chat here. I invite everybody to go to the chat and ask the question as in a written form. We have to move now to the next and last speaker, Laurent. The floor would be yours for the allocated time. So let's go.
Thank you, Pascal. I'm going to share my screen quickly. Yeah. Is it okay for you? Yeah. It's okay.
It is.
Right. I have several different presentations that I'm going to do. The first one is about labs with digital. I try to find some various implementation possibilities, various different approach that I'm going to show you. At the beginning, I wanted to state the objective, so clearly to illustrate various approach to achieve experimentation in labs during, with digital, and particularly in the context of education in UNIVERSEH. So I will not recall why to implement labs with students, provide a practical education, practical approach to learn. verify and extend the theoretical education provided during lecture. It's very important to do the link, as Jean-François stated at the beginning. Learn with success, but also learn with heroes. It's a very important aspect of learning, and it's probably implementing labs is probably a way to implement active education. So I've got a remark. This presentation is made in the context of more or less of BYOD, bring your own device, because as in Universe, we will probably have presential, but also a lot of distantial, etc. So I suppose that we need to be computer system agnostic, meaning that students, we can control what students have as material. So we are mainly based on web interfaces, which is the best, probably the best candidate now to achieve education using digital, because it's clearly the most available interface to everybody. Okay, so a tour. So what I'm going to talk about. The first point is a remote software with students' own device. It's somehow classical, but it's very important, I guess, and I think there's few information to say about that. Next, a BYOD bring on device experimental platform. There are possibility to do that, and it's interesting to explore this aspect. Web interactive simulation, okay. Cross reality in the context of immersive technologies. Real-time control on real remote experiment setups. I will do a small tour on that, and finally I will continue to interactive deferred experiment setups. Okay, so what about remote software with own device? The idea is to access to, you know, in aerospace engineering particularly, but I guess in all domain, business software, I mean, core softwares are important to experiment for students. And sometimes it can be a real problem for making students accessing to those software, because particularly they could be very computer intensive, or they can be also licensed to the university, and it's probably complex. You have to set up VPN, etc. Installation on students' machine. Student machine may be, for example, quite performing, and it's not always the case. It's not the general case. So I guess that a solution, an interesting solution that is more and more used clearly, is what we could call education cloud, where actually students access with their own device, with just a PC or a Mac, which is a low profile computer, and access to using a web browser, a simple web browser, to access to large computers that can be either on the data center of the university, but also in private, public data center like Azure or Google. And it's really interesting to install in this cloud the core application. And what you have to understand is that the application is executed onto this cloud and not in the student laptop. So you can dimension the power as you need. Example of such approach are very large. Of course, there are so many possibilities. The first one is an open source software. I have to say that often the university IT support is needed to achieve that, of course, because you have to set up infrastructure. But it is really possible to do that with, for example, Guacamole, which is an open source software that is able to set up the web interface to any softwares. There are also, of course, pedagogical cloud offer from GAFAM like Microsoft or Google. Azure, for example, is good for that. Finally, you've got to see also software editors like MATLAB, for example, that are providing web interface in such a way for students to accede to MATLAB, for example, to this software, just through a web browser. I put the links there. It's great because it is possible also to include MATLAB into Moodle. So you can build a Moodle class page with many videos, etc., and MATLAB software available. Finally, but of course it is not free; it's private, and it's you have to pay to do that. And finally, Jupyter. More and more teachers are using Python to implement. Any sort of software that they want to make a student use. And I think the best way to teach with Python and is probably the Jupyter notebooks. For example, you can of course install Jupyter notebooks into the university, but there are also public Jupyter notebooks that you can use. For example, Colab is a well-known. Can you see my screen? It's okay. You can see my my screen now, right? You can see Google Colab, and the interest is you've got some documents which are named Python notebooks, and you can mix data and writing, explanation, and code. So you can very easily modify and execute code. Students can execute code, make, for example, a very complex any possibility, any graphics, anything you can do using Python. You can show it in the web page of the notebook. Okay, so I continue this. The second approach, which is more on physical labs, less IT labs, but more physical labs, is probably the BIOD experimental platform you can use. The idea is to make use of student everyday objects that they usually have now to implement labs. For example, one particular object which is very interesting in physics and also electronics is probably the smartphone of the students. Most of the students have a smartphone, and the fact is that the smartphone is classically built on a large set of sensors, many sensors, GPS, a lot of things are integrated. So the idea is to use these sensors to implement labs. There are some solutions to do that. For example, you can go to firefox.org, which is an incredible application. You can transform any smartphone into a real experiment setup. Then you can build on top of this application a lab scenario, a pedagogical scenario that is going to use the many sensors you can have. It's in French. The application is not French. It's not in French, but it's French. The snapshot is in French because my smartphone is set in French. Okay, so but you can set it up as you want. So it's very interesting, and I guess you can try that. Another way to implement labs is a very classical way to do that, is to implement interactive simulation. I mean, a model that is going to be used, a theoretical model, an implementation that is going to be used to illustrate something, a physical aspect or any possibility you can imagine. So it's a very interesting way to do, because in fact there are plenty of possibility, and you can model the reality. You can avoid complexity if you want, or you can put complexity if you want. The point is, the characteristic is probably that it's not the reality. Of course, it's a model that is going to drive the simulation, but of course, it can be very interesting and particularly accurate in some cases. And but the student have to understand that it's an illustration of the theory by the theory, not by the reality. Okay. Many possibility. You have many of tools to do that. Many of library of already made simulators, still accessible through a simple web browser. For example, just two of them. PhET is so it's a library where you can find many things, as you can see now. Okay, in physics, chemistry, math, etc., and on different level of education. And okay, you can see various way to achieve that. And sorry, I didn't try this one, but I can try. And it's very easy for students to do something with the tool. Of course, the problematic is that you have to find the right topic for your course, and it's not so easy to do, not so easy to find, but so you can be lucky and you can find a very interesting simulator that will particularly illustrate your course. You can also develop your own simulators, but for that you need a minimum computer development capacity. Okay, it's not for everybody, and it can be quite complex sometimes. So you have to know that. If you want to build things, I wanted to do a zoom on another tool, which is Geogebra, which is more or less the same aspects, the same possibilities, but in that case, it provides a very simplified online development environment that you can use to model geometrical physical animations. Okay, I talk about that because it's very used particularly in secondary education in France, but actually we use it in UNIVERSEH for illustrating very complex equations. I can show you something. You can have here few of our developments, and for example, engine failure in a plane. Okay, we just built models using the equation in the lecture. Okay, of course, all right, and then you can for example show that even with
Laura, excuse
yes?
me, we can
yes?
see your screen.
Oh, okay, you cannot see it. Okay,
yeah,
good, not good. I am doing a lot of demonstration, and I wanted to know that. Okay, I'm going to I have to share directly okay. You should now see what I mean.
yes.
Sorry. So GeoGebra is that, and I wanted to show that it's possible for example, for a student to understand how a plane can go right, even if he has an engine which is not working, for example. So we use that a lot, and we find a lot of various. We developed various small simulator like that. Okay. So I need to switch all time. So I'm going to switch on this one. Can you see? No, you can't see.
Yes.
Yes, you see my presentation?
Yes.
Okay. So this is Geogebra. Now, few information about cross reality. Cross reality, you know, is a federative name for calling virtual reality, augmented reality, mixed reality. I'm not going to show you a lot of things about that, but I think this must be mentioned because there is plenty of possibility depending on what type of labs you need to implement. But sometimes you've got labs that are very expensive to achieve because you can, for example, use I don't know, a rocket. You could use any system, any complex system in this environment. I show you the difference between augmented virtual and mixed reality. Augmented reality is when you augment the reality with for example, such a tool. The virtual reality, you know, you have to have a mask, glasses on your eyes, and you don't see the real world. But then you can access to a virtual world and interact with it, and it's very interesting for manipulation sometimes. And finally, mixed reality is when you through a smartphone, for example, or through a camera, you can do such integration, which can be very useful. As you can see here, you see the video? Yeah, it's right.
Yes, it works.
You can illustrate very complex aspects that could not be possible to do physically. Okay, so that's it. Fine. Yes, this is now another way to do labs, a real-time control on a remote experiment setup. In the context of distant learning or hybrid learning or whatever, one problem is to access to labs, to the experiment setups. Actually, it's not physically possible to go and to use it. So some people try to remote control the systems that they usually use during the courses, during the labs. And so the principle is to remote control setups. The characteristics, of course, you need to do that to have the experiment setup, but in addition of that, you have to have some sort of meta system that is going to be able to manipulate the lab. And you need, of course, to automatize the manipulation of the experiment setup. Okay. One important thing to understand is that if you access to a physical experiment setup, of course, you have a problem of scalability. Just one student can access at a time to one experiment setup. It is quite important to know that. So there are different tools that can do that. Of course, you can understand that it's not so easy to implement. You have to do some quite a large set of things to do that. But for example, WebLab Dosto is an open source tool that can be installed in university without any problem, and provide the way to do that, all the IT support to do that. And if you want to use it directly, you can have a look to Labsland. Labsland is actually a startup. It's a startup for a spin-off from WebLab Dosto, offering particularly online services that are really good when you have to set up, in addition to theory verification, when you have to manipulate and even to do creative things remotely, because what happens is that you are going to access to physical things like there's electronic boards, and you are going to be able to build something on those electronic boards. I'm going to share you that. Let me know which is the screen. This is no. I don't see it. Do you see my news share? Yeah. Is it okay?
Yes.
Where I can see the mouse as well. Yeah.
Yeah. Okay. This is LabsLand actually, and this is one of their multiple laboratories they can do. They provide, and this is, for example, here an electronic laboratory. Sorry, it's not this one. View experiment. I'm going to try physically to do that. Yes, access. All right, it's not working. Well, anyway, it's as you can see, the student can build really some sort of electronic system, and can use various tools to measure, to do all he would have to do in the reality. Okay, so he can use all this oscilloscope. As you can see, you can use many the classical electronic tools to do that. It's very interesting, but of course, if you want to access to a large number of students, can be a problem. Okay, and you can also LabsLand offer the possibility to implement your lab into the system. Okay. So I come back to my presentation. No, see, now.
Just Laurent, can I make just a precision on LabsLand? In this particular experiment you show, you can have 100 of students using it at the same time. They have thinking this one in particular to be scalable. This is not the case for all of the experiment. When you have Arduino bots, okay, it's not very good, but they use the device only on request and only when they really need it. So it's very intelligent, because on the same device, in fact, there is many students who can work on the same device because they do not make a measurement. So when they need a measurement, they take the device for the student. And so in practice, students do not wait very long time. Really, it's nearly real time. So they are really thinking of that. So it's a good job they have done. It's not perfect, of course, but they have make a good step.
Yeah, true. Okay, finally, I'm going to finalize my first part of presentation. It's it's actually another way to do more or less the same thing that WebLab, but not for all use cases actually. It's the possibility to digitalize, to record, if you want, all facets of a setup of a set of experiments achieved onto a particular experiment setup. I'm going to zoom on that because actually Irion is trying to implement this approach for UNIVERSE, and is trying to provide for you the platform that is going to ease that and the support also to do that. So I'm going to now to focus on Irion. Okay. So Irion is is a platform that is implemented and particularly experiments that are implemented into the WP 4.7 of UNIVERSE, and I'm going to try to zoom on that. We begin by the problematic. The problematic is that experimental setups, large experimental setups, are usually not very robust. They are they are difficult to make. It's difficult to make them to work properly. usually, because they are not done to be used by many students, etc. So labs are based on physical installation that may be intensively manipulated, and I think that robustness is very important in this in education. Experimental setups can cost a lot, depending, of course, of the experiment setups. But if you want to set up to do an experiment with a plane flying and with you know, sensors and etc. to do, it's very expensive. And I guess this is actually another big problem. The fourth problem is experimental setups usage scalability. As we discussed a few seconds ago with Jean-François, is the capacity to serve a large number of students at the same time, because you probably remember, sorry, you probably experiments that you have to organize a long lab period in such a way to see everybody, and it's quite complex. And finally, the accessibility of the experimental setup is usually physical. You have to go in the lab and etc. with engineers that are going to help students to do the lab, etc. And sometimes you would want to provide that from outside, from remote education, for example, and it's difficult. So the approach in deferred experiments is clearly to have an experiment. Sorry, the draw is not here, but it should be an experiment there, and you digitalize. You do experiment with your experimental setup, and you digitalize everything you want, everything you need. I mean, for example, the video, the noise, the sound, but also the result of sensors, etc., the measurements, everything you need, you capture them, you digitalize them, and then you put it into basically a large database that is going to record all the facets of the experiment. And then once captured, you can provide an interface to students, a web interface, of course, to students that are going to be able to set up the experiment exactly in the same range that the experiment tests has been achieved, and then we will serve the results to the student. It's a very easy approach, very simple approach. But so the process is there. You designed a test. Sorry, the student designed the test, understand what he has to do. He set up, he opened the platform, on etc. He set up the parameters. He's looking, is seeing what happened in real time. I mean, in real time, he's doing the experiment achievements. He's got video, sound, graphical, etc. And then he's able to analyze the result because, for example, he can get the data and he can get the course, the graphs, etc. I can show you if you want a few seconds on that. I'm going to switch. Switch. Okay. Oh. Okay. I think you see the aerial. I'm going to show you the prepared version. So as you can, this is just a website at the moment, and you can go to the lab experiments, and then you can see the various experiments we achieve at the moment, or we are actually producing from now. For example, I can show you this one, which is an classical automatic experiment where you have to set up payday gain in such a way to parameterize this automatic scheme and to be able to do something with this some sort of helicopter. There are two systems that are controlling the attitude of that. And then, so the student is able to control the payday as he wants, actually, and then you can just start the simulation, not the simulation, sorry, the experiment, and you can see in real time what happened in terms of sound, of video, and finally in terms of measurements. Okay, so. Another very interesting one is this one, which is actually a reactor, a real reactor in either Supero we have, and so we can set it up. Okay, I'm just going to show that, and this is actually a real experiment of a reactor engine, a turbofan. Which is going to start, as you can see here, is going to start. Yeah, I don't know if you understand the lesson, the noise. There are a lot of noise here. Okay. Okay, this is what we can do with Uriel. And so I'm come back to the presentation. So up. Okay, can you see my PowerPoint? It's okay?
Yes, yes, I can.
So okay, so Uriel has a lot of target experiments profile. In fact, there is a lot of possibility offering this to implement. I'm not going to explain all of that, but this is actually all the situation where Uriel can be used. For example, when as you can see with the reactor, when it's very dangerous. It's so dangerous, this experiment, that we cannot, even in reality, we cannot go to the room where the reactor is working during the test. So it's a very dangerous and expensive experiment. And so I think it's very interesting in this case. It's unique when you have a unique system, not multiple, but unique. So I think it's interesting to implement things. When it's automatable also it's very interesting, because otherwise you have to scan the experiment manually with you have to do it manually, and it can take a long time if you want a lot of tests, etc. So you've got a large set of possibilities of and just one or two of those profiles are just necessary to be interesting to digitalize your experiment in Europe. Okay, the use cases now is when we use it in various ways. Once the experiment is digitalized, you can use it in various ways. Actually, you can, for example, introduce labs with that, because it's a good way to do some sort of flipped classroom, where when before going to the real lab, the student is going to begin to try things, etc. Then when he will be on the lab, he will be probably more performing, and he will probably get the information more, the knowledge more clearly. Okay, but you can do a lot of use case. Of course, an interesting one is when you are doing a MOOC with thousands of students. It's very interesting to provide this way, because it's scale very good. Okay, so there are a lot of possibilities. Oh yes, I'm very late. If you are interested, I am going to I will give you this URL. You can go there, and then you can register yourself if you want to have information, etc. about that. And in the June 18, there will be a more focused seminar. Okay, it seems I'm 10 minutes late. I'm going to switch.
The previous presenter was a little bit late as well. We took a few minutes late here and there, so well.
I'm going to try to go faster.
Yeah. Anyway, thank you.
Okay, so this is a completely different thing. I mean, not really different because you can integrate URL labs into these ADNs, but I'm going to present another aspect of what is done in WP4. Okay, we've got the state. The problematic is we have various learners profile, students, alumni, people in MOOCs, for example, and employees in continuous education. And we've got a large possibility of models, of education model, for example, in campus education, with you know, flipped classroom, classical lecture, etc. MOOCs, massive open online courses, SPOC, small private online courses, or even I will introduce in the next slot micro learning. So what we would like to do actually is to implement digital, but to try to optimize the time consuming process that we need when you have to implement digital things. It's very important. It can take a long time to do resource, etc. Another thing is how to produce efficiently quality-based resource. I mean, the idea will be probably to have a performing resource. When you decide to spend time on something, usually you want to this thing to be good, to be performing, okay, and with in quality. So another point, very important in this context, is how to reuse digital resource. As we state from the beginning of this presentation, for example, real experiments or labs-learned experiments, etc., can be reused in various systems, various education programs. Particularly, we saw that real experiments can be used in MOOCs, SPOC, flipped classroom, etc. So I think it's very important to be to offer this possibility with resource, with you know, learning resource. Okay, and finally, the next step in education probably is to go to adaptive learning, to be able to adapt to the students more efficiently. And I think it's another point that have to be taken into account. What we think about that is in such a way to try to reply to all this question, we defined a unit named ADN, Aerospace Digital Nuggets, that aims to feed the various education programs, various modalities, the best it can. So the idea is to build these ADNs in such a way to feed, to be reused in maximum to various possibilities. So what's an ADN? ADN is firstly a short focus resource. It's less than 30 minutes learning time for students. Okay, so it's some sort. It's very short and very limited. Next, it's a decontextualized resource in such a way to optimize the capacity for ADN to be reused in various situations, various pedagogical situations with various type of learners. The third point is it's multimedia and interactive. It integrates not only, for example, a text or a video, but it also have to be active. I mean, the students have to be active in this ADN, and it has to integrate some interaction with the students in any way. A quiz, stuff like that, in such a way for the student to be able to check if he understood something to what happened in this ADN, but also, why not IRL experiment, a lab with IRL implemented into the ADN, okay? And finally, it is fully qualified, I mean, with metadata like author, description, learning incomes, etc. Why? To be able to manipulate the ADN without having to watch into. And it's very important for us to be able to manipulate the ADN because you have to be able to find them, for example, if there are a lot of ADNs, you have to recover them. So the overview of the ADN ecosystem is like that. We implement actually some sort of repository where a centralized repository where we're going to be able to create and to store and to serve the ADN to many platforms and many usage. Okay, it will be possible. Of course, each author stays the author and the owner of its ADN, but he can share it with other students if you want, or he can at least, and it's often a very important usage, he can reuse by itself the ADN in various education programs without having to copy it in the various platforms. You just have to set it up properly, and you will be able to integrate it very easily in various education platforms. I will show you. It is possible to use it in campus teaching with flipped classroom, for example, as additional resource, refresher, to go further, for example. It is possible to use it in blended learning, of course, and in distant learning. We are able to set up MOOCs, SPOC, or even self-training with that. Just a demonstration of what is physically an ADN. So this is an ADN on airplane geometry. As you can see, it's very short, okay, less than 30 minutes. It's very simple. It's not a complex system to achieve. This one is, but as we know that we are going to reuse it in various ways, this one is probably used in 10 programs, in 10 different programs of our institute in France. So it's interesting to invest time and probably a bit of money on it. So for example, as you can see, we used for this ADN a drone to film, to take video of plane, etc. And we've got also augmented reality in such a way to explain things very in an interesting manner. Okay. So this is the learning part, and then the next part is here the interactive part, some sort of a lab when the student is going to apply what the professor explained during the theory, and is going to do an exercise. This is actually Geogebra that I showed you a few minutes ago, and you can see, and then you can test if is right or no. I'm wrong. Okay, actually he has to do the lab, and he has to get the value there. Okay, so this is an example, an interesting example of ADN. And what I wanted to do to show now is that we can. Do you still see my web browser? It's okay for you? No? No. Wait a second. Yeah. Yes, you should see it. As you can see my web browser on online.
Yes.
Super online.
Yes, we do.
So I wanted to show you now that this ADN that I directly access through a web page can be very easily integrated into sorry, I have to log in. Can be integrated into a course like this one. As you can see, it's a classical Moodle course with a set of sections, and I wanted to show you the same. Where is it? This is actually the ADN we saw a few minutes ago. Actually, the same one that is coming from the same repository. And you can look that we've got the same system, and so it's very easy to do that because you can do course very quickly once you did few ADNs. Okay. If you are interested by this approach and this way to implement digital, please register yourself using the URL and come on the June 17. This one, the last one was 18, to a webinar on this approach. Finally, do we have 5 minutes more?
Well, try to be short.
I'm going to be very short because actually
yes,
mLearn is still in the same approach, but the idea in the micro-learning approach is to provide a new way to present those IDN. As we saw that the first way to use it is to integrate it into MOOC platforms or LMS, Moodle, etc. But we would like to build some sort of platform that is going to where it will be possible to use directly the IDN from the students. They will be able to choose and to go directly to the ADN. So I'm not going to as it is actually illustrated here. You've got the LMS approach, but what we wanted to do here is actually to be able to access directly to the micro-learning nuggets and to provide to students the best tools to learn with it. I mean, for example, a searching engine at least is necessary, but we at the end we would like to also provide, for example, such filters like we should be able to explain to show them the most used micro modules or the modules that are used by their cohort at the same at this time your friend are just looking at that. So it could be interesting for the student to know that in such a way for them to go and look at this type of information. Suggestion, for example, we have to implement, of course, machine learning and stuff like that to do that, but it is actually the aim at the end. I can show you now, just to finish the results. We are implementing that now, but I can show you, or no, I cannot. Can you see my web browser now?
Yes.
No. Yeah. I can show you the level of achievement we are from now. Just a pre-production, but it's not it's not finished at all. But this is actually the pre-production we have. As you can see, we can have those those selection. At the moment, the selection are completely static, etc. They are not interesting, but it is actually what we can do, and we can of course have access to the repository like that and have a look to the various things, etc. Okay, so this is working, but this is not deployed, of course. This is first version, alpha version, but it is still working more or less. Okay. Come back to Zoom. And I stop my sharing. Okay. Okay. Pascal, I'm over.
Okay. Thank you very much, Laurent, for these, and Eric and Jean-François for these very interesting presentations. So we are going to the question and answer phase. We are a little bit late, but anyway, I think it's important to listen to the attendees if they have any question. So please. No questions. Oof. Well, if yes.
Not just, yeah, I put the link. If you are interested by all this WP4 work, you can register there.
Okay, well, if we don't have any other question, I would like to say some conclusive words regarding the different tools that have been presented this morning. You can find here a list, but well, don't worry about if you don't have that list already, because it will be available from the website in the 5-star document, because you have to remember, you have to pay attention to the fact that the use of these digital tools will not be mandatory, but you are encouraged to use them, of course. And if you want your course to reach the tool, to get the tool from the digital aspect, related to the digital aspect, then your course will have to use to include a significant use of the following tools. But among them, there are some which are underlined or in bold, and there are some that's a kind of code. The one indicated in bold will be supported by WP4, and you're of course encouraged to use them. And those which are underlined are free tools, and you are also encouraged to use them. And I can in here copy and paste the link that Laurent provided, because as he mentioned, there will be some dedicated webinars organized by WP4 on some of those softwares and those platforms. Well, iReal, ADN, MLearn platform, which are included in the WP4 and in the whole Universe project. So first concluding word I wanted to say. Well, we in WP3 and with cooperation of WP4, we co-organize 3 webinars. The first one was on April the 13th. The session has been recorded and will be soon available on the YouTube specific chain. I'm arranging this with Luleo, who is in charge of WP7 regarding communication and all those aspects, and as well for the today's webinar. And there will be another one next week on May the 17th. Well, not exactly next week, but within more than 1 week time. It will be focused on the active learning techniques, and all the speakers will come from University of Luleo. So I invite all of you to get involved in these techniques and participate in this webinar. So, well, there are some, on that slide here, I showed the different contact points of contacts in your own universities regarding WP3 and WP4. So as well, this list will be included in the slides that will be available online. So feel free, if you have additional questions, to first ask that question to your point of contact in your home university. And then, in case you can also write an email to me or to Adam Walters, who and we are co-leaders of WP3 here. Or you can also, if you have some particular question regarding WP4, as University of Luleå's leader, you get the name of the person in charge here, the contact point for WP4 at the European level. So here are my last words. Well, if you don't have any other remarks or comments, I'll be happy to close that session and have lunch. I wish you all the best for the coming weekend, and hope to see you for the next webinar, which will be given by Luleo on May. Well, where is that list? Okay, that one here, the one which is underlined here. The next webinar, which will be given by Luleo on active learning techniques. And as well, remember that you will have several specific webinars given by WP4 on the tools which will be produced, whose production will be enhanced during this project, this university project.
I can just say that the 26th of May, we will have a workshop on the student to teacher, how to involve and activate students more in the teaching. So if you're interested in that, please contact me. I write my email address in the chat.
Yeah, I am. Could you send the, well, could you send there, is there an invitation or something?
Yes, there is an invitation. I have sent it to the respective contact persons of each university.
Okay,
but I can send it to you as well if I get your email address. Please just mail me anyone who is interested, and I will send this on.
Okay, thank you very much. I think that for all these webinars, we'll have to create a specific list that will be displayed on the website, just to to put all the interesting information at the same place. Okay, thank you very much, Eric.
Thank you very much.
So, well, I wish you all the best then for this end of the week, and well, hope to see you in the next webinars, and working all together as a strong and fruitful team on this project. So,
see you. Bye bye.
Thank you. Thank you.
Bye.
Thank you. Bye bye.
Thank you very much.